In this video, we will solve the example problems from Chapter 6. Example 6.38. Find the vector and Cartesian form of the equations of a plane which is at a distance of 12 units from the origin and perpendicular to 6i cap plus 2j cap plus minus 3k cap. So this is our normal to the plane, and the plane is at a distance of 12 units. So you're given the distance and the normal. So let's proceed. So our D vector, which is perpendicular to the plane, is defined as di cap plus 2j cap minus 3k cap, and our distance P is defined as 12. Therefore, if d cap is the unit normal vector in the direction of the vector di cap plus 2j cap minus 3k cap, then we can define d cap as d vector divided by the magnitude of vector d. So, solving, our magnitude of vector d is 7, which will be the square root of 6 squared plus 2 squared plus 3 squared, which would be 7, times the vector d. So, further solving this, we can say that if R vector is the position vector of any arbitrary point x, y and z on the plane, then this is the formula that we are using, which is R vector dot product with d cap is equal to P. The vector equation of the plane in normal form is given by R vector. Our d cap here is given by this. So substituting that value into this, you get this, which is equal to 12. So that's the vector equation form, which is the first part of the question. Now for the Cartesian form of the equation. So let's substitute our vector as xi cap plus yj cap plus zk cap in the above equation, which is this equation here. So substituting this into this, you get this equation. Further, applying the dot product in the above equation and simplifying. So when you apply the dot product, x into 6 will become 6x, y into 2 will become 2y, and z into minus 3 will become minus 3z, and our 7 will go to the other side. So it will become 12 times 7, which is 84, which is the Cartesian equation of the required plane. Example 6.39. If the Cartesian equation of the plane is 3x minus 4y plus 3z is equal to minus 8, find the vector equation of the plane in the standard form. So what we given is the Cartesian equation. We know that if L, M, N or the direction cosines of d cap, which is the normal unit vector to the plane, then Lx plus My plus Nz is equal to P, where P is the distance from the origin to the plane. So we can rewrite our equation. Our d cap can be rewritten as, since L, M and N are the direction cosines of d cap, so d cap will be equal to L I cap plus M j cap plus N k cap. So our Cartesian form of the equation is, our vector form of the equation is R dot d cap is equal to P. So substituting L, M and N in d cap, further we can say R vector dot product, or L, M and N here are 3 minus 4 and 3. So it's 3i cap minus 4j cap plus 3k cap is equal to, our p is minus 8. Or we can rearrange this equation as r dot product with minus 3i cap plus 4j cap minus 3k cap is equal to 8. This is the vector equation of the given plane in standard form. Example 6.40. Find the direction cosines of the normal to the plane and length of the perpendicular from the origin to the plane, which is given by this formula. Now, we know that this can be defined as our vector d, and we can call 5 as q. Now, d cap, which will be the unit vector in the direction of the vector d, which is 3i cap minus 4j cap plus 12k cap, will be equal to, d cap is equal to the vector d divided by its magnitude. So the magnitude of vector d will be square root of 3 squared plus 4 squared plus 12 squared, which will be 13. So if you divide the vector d by 13, you will get d cap, which is the unit vector. So if we divide this entire equation here by 13 and rearrange it, then this is nothing but our unit vector, which is the normal to the plane. Okay, so this 5 by 13 is the distance of the plane from the origin. Therefore, this is in the form of our normal form of the equation, plane equation, which is r into d cap, or dot product with d cap is equal to p. So from this equation, we infer that our d cap is equal to, is given by this, is a unit vector normal to the plane from the origin. Therefore, the direction cosines of d cap are 3 by 13 minus 4 by 13 and 12 by 13. So we found the direction cosines of the normal as required, and the length of the perpendicular from the origin to the plane, which is the distance of the plane from the origin, is given by this p, which is 5 by 13. Hence our result. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.